Hello. Today we're going to look at finding the maximum and minimum values of trigonometric expressions. So this comes just after we've looked at the chapter on the R formula of solving trigonometric expressions, and you're going to see that there's an application of that same concept here. So here the question says find the maximum and minimum values of the following. So before we go further, in all the questions where we want to find the maximum and minimum value, we have to either express that equation in the form of r cos theta plus or minus maybe alpha or beta, or r sine theta plus or minus maybe, where alpha is what is in the question. So if the question maybe here it was beta, this would be beta, and this is like a new unknown you've introduced. So, and plus or minus depends, even if for it to be cos or sine depends, and we're asking ourselves what does it depend on. Now so for this, for what determines whether it's cos or sine is going to be, so let me say, let's maybe let cos theta plus sine theta be equals to r. So now we are saying for it to be cos or sine, what determines is the first, because you see this has two expressions, cos theta plus sine theta. So what determines for it to be cos or sine is the first expression. So here the first sine is cos is coming first, so it's r cos, and the first term when you open this bracket should be theta. What that theta is representing whatever is in question, or like the unknown in that trigonometric expression. And now what determines whether it's plus or minus? You have to know the compound angle formulae. So you have to know that when you subtract two angles in a cos, you're going to get a plus, like they will eventually add. So that's why here I put minus theta. Then I'll expand this expression. So this resembles a, so when you expand this will be cos theta cos alpha plus sine theta sine alpha. This is equals to r cos theta cos alpha plus r sine theta sine alpha. So we have, so this is cos theta plus sine theta is equals to that. So the next part we go to is called equating the coefficients. So here you see cos theta, this is cos theta, this is sine theta. Now we equate the coefficient. So here the coefficient of cos theta is 1. The coefficient of cos theta this side is r cos alpha. So we also go this side. So this is the coefficient of cos theta. Then I will go this side, the coefficient of sine theta going to be, this side it's 1. 1 is going to be equal to r sine theta. So this side we divide by r. Okay, divide by r on both sides, so we get 1 out of r is equals to cos alpha. Then we said we get 1 out of r is equals to sine alpha. So from SOHCAHTOA, sine, this is opposite out of hypotenuse. From SOHCAHTOA, this is adjacent out of hypotenuse. Then we draw this on our triangle. So this is alpha, opposite is 1, hypotenuse is r, then adjacent is also 1 with a, b, c. So a squared from the Pythagoras theorem, a squared plus b squared is equals to c squared. So this is 1 squared plus 1 squared is equals to r squared. So here we have 2 is equals to r squared. So we get r is equals to root of 2. Then we also have to obtain, so we come and say obtaining alpha. So here what will we have? We'll have tan alpha is going to be, from SOHCAHTOA, it's opposite out of adjacent, so it's 1 out of 1, which is 1. So alpha is going to be the tan inverse of 1, and alpha is going to be 45 degrees. So initially we said cos theta plus sine theta is equals to r cos theta minus alpha. So now we can rewrite it, but while substituting, plus sine theta is equal to, this is root of 2, which is r cos, then theta minus alpha. Found our alpha to be 45. So this is now what we have. So now the question wants us to find the maximum. So the question wants the maximum of cos theta plus sine. So question wants the maximum of this. So the maximum of this is going to be equal to the maximum of this. Same concept we've been saying. So this is the maximum of this times maximum of this. And here we're going to get, this is root 2, because the maximum of root 2 is root 2, times, we say the maximum of any cos or sine is 1, So the maximum of this is root of 2. Now I want to get the value of theta at which the maximum occurs. So we're going to come here and say, since we say the maximum, this is 1, now we can say theta minus 45 is equal to the cos inverse of 1. Now we said every time you have, you're dealing with the cos inverse of 1 or sine inverse of 1 or the sine inverse of 0 or the cos inverse of 0 or negative 1, you draw the what? The quadrant. But for this, I'm just going to sketch it from the calculator. The cos inverse of 1 is 0, so theta is equals to 45 degrees. But I've told you for normal numbers, you usually have to do this quadrant. This is 1, negative 1, and you put 90, 180. You get the multiples of, okay, this. You get the multiples of 90. And now for the graph of sine is, the graph of, sorry, so this is cos theta and this is theta. The graph of cos theta is symmetrical. So it's like this, like this, like this, like that. So you plot this. After plotting this, you now come, for example, here 1 to the cos inverse of 1, you come to 1 and you look out for 1. So here, for at 1, the cos inverse of 1, we have 0 and we have 360. But here, 360 is already out of the range we need. So here, okay, we've gotten the maximum, the value of theta at which the maximum occurs is 45 degrees. Then we also come and say, we record our equation because we also want, the question also asks us to find the minimum values. So come and record this. We said cos theta plus sine theta is equals to root 2 cos theta minus 45. So we now say cos theta plus sine theta, the minimum of this is going to be equals to the minimum of this. You see, minimum. So this is going to be the minimum of root of 2 times the minimum of this. And we say the minimum of any cos or sine. So the minimum of this is the minimum of root of 2 is root of 2 times negative 1. So the minimum of any cos or sine is negative 1. So we now want to find the value of theta at which the minimum occurs. So I will say this is equals to negative 1. So we say theta minus 45 is going to be equal to the cos inverse of negative 1. So now here to find the value, you just come to negative 1. And sorry, here I drew it badly, but negative 1, you see it crosses. Okay, let me see from the calculator. Cos inverse of negative 1 is 180. So you see even here, we see 180 is matching. So you can see theta minus 45 is equals to 180. So what is theta is 180 plus 45. So what's our value of theta? Value of theta is 225. And usually the questions want you to like write the minimum value is negative root of 2 and the value of theta at which it occurs, you write it like this. So even here I would have written root of 2 comma 45 degrees. So that's how we find the minimum and all minimum values of trigonometric expression. So let's look at, so this is the exercise first. So we've done this. Then now you have this. So maybe just to give us a hint, when you have 4 sine theta minus 3 cos theta, I told you all these expressions have to be written in either r cos theta, because here all of these have theta, plus or minus alpha, or r sine theta plus or minus alpha. And I said for you to choose if you're using cos or sine, you depend on the first expression. So this is going to be r. We're going to choose sine because sine is coming first. And what helps us choose the sine? So from the compound angle formulae, for sine, when you have a negative, it will remain a negative. If you that I refer you to go and review our compound angle formula. But here, so this will be equals to this. Then you work out the same also even here. So I think now we can try out this. So for this will be r sine theta plus alpha. Then the same similar solution. And now from that similar concept, you can solve these equations. Actually, I don't even think there's a new thing. As long as okay, let me try. We're going to try with this first one, and then can try out the rest, but it's the same exact concept. So you're going to see. Okay, so this is the exercise for us to try out. We're going to just see how an example maybe using this. But the most important thing in all these questions is knowing how you're going to express the term in now here. We're going to look at this. So here we have 3 cos theta plus 4 sin theta is equals to 2. So we said when solving any equation using the R formula, and the first thing before that we said all trigonometric equations that can be solved by the R formula can be solved using the T formula. So for this is 3 cos theta plus 4 sin theta is equals to 2. So if you solve it using the R formula, we say you have to express it in the form of either R cos theta plus or minus. This means it can be plus or minus, or in the form of R sin theta plus or minus alpha. And we said what determines if you're going to express it in the form of R cos or R sin is the first term. Now here the first term is cos. So you're going to express it in the form of R cos. Open this bracket, theta has to come first as we said. Then now you just have to know the compound angle formula for cos, because the compound angle formula for cos when we subtract, like if it's a minus, what we'll get will be in form of a plus. That's why here we're going to express it in form of this. Then you expand this. See, expand this. When you expand, this becomes a plus, and I think now from this I'm going to pause, then I display the final answer because I don't want to make this video very long. So after that, this is how we went on. Expressed it in the form of R cos theta, R sin theta, then you equate coefficients. You get this, you get this, then you put it into this right angle triangle. Then you get the value of alpha from the Pythagoras theory. R is 5, and then you get alpha from tan. Alpha is 4 out of 3. Then you get alpha is 53.13. Then after that we substitute it back, so we say 3 cos theta plus 4 sin theta is equals to 5 cos to theta minus this. And since this is equals to this, we can now equate this to 2. Then now we can solve for theta, and our value of theta is going to be 66.42, but we get the other values from these quadrants. Yeah, and this is how we solved this. And I was saying here that you can eventually prove what the value of theta you get. You can try to substitute it into the equation, this original equation, and you see when you substitute, you actually get that we say left hand side, then this is the right hand side. So when you substitute these things into the left hand side, you get 2, then the right hand side is 2. So we've proved. So marks the end of this. Thank you for following.